Alright, so in this video we're going to revisit 4.1. So you remember I started with 4.2, so now it's going to be back to 4.1, which is going to be on periodic functions. So in this subtopic, I'm going to explain to you what is a periodic function, what is the characteristic of a periodic function, and I am going to even show you like how do we sketch for periodic function. So in this chapter, like the first step is for you to sketch the graph, because from the graph you're going to identify whether your function is even, odd, or neither based on what we discussed before. So we're going to determine, so from your sketching, whether it's going to be odd, even, or neither. So that is why, so if you sketch the graph wrongly, automatically you're going to identify, like for example it's supposed to be even, but from the graph it become odd, automatically like your whole calculation is going to be wrong. So that is why this subtopic is going to be really important. So it's going to be the beginning of your calculation. It's always start with graph sketching. Right, so that is why instead of like explaining about the periodic function right away, so I'm going to do a little bit of revision with you guys on how do we sketch for function. I know that this might be trivial for some of you, but believe me that every single semester I have found many students struggling with the idea of sketching graph. So if you're already like you think that you're already good enough, so no need to no need to proceed with this video, so you can simply proceed to the next part, right? But if you need to revise on this, so listen very carefully. So I'm going to start with a very simple graph. So that will be a graph of y equal 3. So what happened is that we know that the value of 3 is a constant, so this is simply going to be a graph of a constant. If you remember the equation of a straight line, y equal mx plus c, so the m over here, it stands for the gradient. If the gradient is a positive value, so what happens is that the graph is going to be going up, right? So if the gradient is a negative value, so your straight line is supposed to be going down. But for this case, when you have a constant, so your m value is simply going to equal 0. So that is why you don't have any x in there, because m is equal 0. Okay, so when you have m equals 0, it means that your graph is not going up, so it's not going down either. So what happens is that your graph is going to be a static horizontal line. It's not going up, not going down, it's simply going to be a static line, or going to be a horizontal line. So that is why, so if I were to sketch for this graph y equal 3, so this is going to be my x-axis, this is going to be my y-axis. So basically this variable on the right hand side, so determine the vertical axis, and whatever variable that goes on this side is going to determine the axis, the horizontal axis. It doesn't necessarily be x and y, it could be anything. And for this case, first of all, so we are going to identify where is y equal 3. So for example, let's say y equal 3 is going to be somewhere down there, somewhere up here. So all you have to do is put a horizontal line across y equal 3. So that's how the graph looks like. That's it. So that is going to be the graph of a constant. So please bear in mind, every single time you have a graph of a constant without any x, that is how your graph is going to look like. Or if I would show you another example, so let's say if I have graph of y equal negative of pi. So do not find this intimidating, because if you use your calculator, you will find that the value of pi is simply going to be 3.172 and so on. I don't remember the rest of the numbers at the back, but the main point is that it's just a graph of y equal negative 3.172. So if I were to sketch the graph, so it's going to be the same idea as previously. So this is going to be my x-axis, this is going to be my y-axis. So negative pi is probably going to be somewhere down here. It's sketching, it doesn't have to be exact scale, right? So you just have to, you want to roughly see the shape, how does it looks like, whether it's going to be even, odd, or neither. And of course, since it's a graph of constant, so it's simply going to be a horizontal line that looks like this. So this is a graph of a constant. So now let's extend the idea. So instead of a graph of a constant now, I'm going to start sketching the graph of a straight line. So like example, let's say I have a function of y equal to x plus 1, and I'm going to give it a specific domain. So instead of like having the graph being sketched from negative infinity to infinity, I'm going to limit that this graph is going to be for x values from negative 1 until 2. So it's going to make it easier. Okay, again, so the scale, it doesn't have to be exact, it just have to be roughly. And usually what I will do is I'm just going to pick two values, the highest and the lowest one. From here we know that x equal -1 is going to be the lowest point, and the highest point is going to be at x equal 2. So how do we determine the value? It's going to be, the idea is going to be from the coordinate. So here what you're going to do is you're going to substitute the value of x in the equation, and from that you're going to obtain the value of y, and that is how you are going to get your coordinate. Okay, I'm going to pick the highest and lowest value when x is going to equal -1. So when I substitute into this equation right here, I will get 2 multiplied by -1 plus 1, and that is going to be a value of -1. So -1, for example, it's going to be somewhere down here. Okay, and when I pick another value, the highest value of x, which is 2, so I will get that y is going to equal 2 multiplied by 2 plus 1, which is going to equal a value of 5. And according to the equation, y equal mx plus c, we know that the value is going to equal 2. So this graph is going to be increasing, it's going to be going up, and intercept is going to be a value of 1. So for example, like intercept might be somewhere over there, so I have to remove my 2, it cannot be there, else the intercept is going to be wrong. For example, let's say if I were to sketch the graph, so it's going to look something like this. So let me put a different color. Let's say I use a blue, so that is my graph is going to look like. I'm going to put a 2 over here, so this is going to be 5. Again, you don't have to be very exact with the scale, it doesn't really matter, as long as we know that this is going to be a straight line. Let me do that again. Let me sketch that better. This is a bad graph. Let's see, my -1 is going to be somewhere over here, and this is going to be my 2. So -1 somewhere down there, and 2, 5 is going to be somewhere up here. So all I have to do is connect these two. So I'm going to put it here, because this is supposed to be a value of 1, because the intercept, the c value, is going to equal 1. So that's roughly how it looks like. Again, it doesn't have to be exact, you just want to see the shape, that the graph is going up and the intercept is going to be at a value of 1. Okay, so that is going to be the graph of a straight line. Okay, now let me change that slightly. What if I were to write this as f of t is going to equal 2t plus 1, and my t values are going to be from the same value, which is going to be from -1 until 2. So what will be the difference between these two, number 2 and number 3? So actually, they are going to be exactly the same graph. The only difference will be the axis, as I mentioned to you before. So this variable here is going to determine the axis, the vertical axis. So here this is going to be y, and the variable on the right hand side is going to determine the horizontal axis, which for this case is going to be x. But for number 3, what happened is that our axis is no longer y and x, but it's given by f of t and also t. So this is what is going to happen in this chapter. I'm no longer going to be using y and x. Everything is going to be in terms of f of t and also t. But don't worry, in terms of the sketching, the idea is still going to be the same. The only difference is now this is going to be t, and this is going to be f of t. But when I sketch the function, so it's still going to look like this. So I'm going to have a 2 somewhere over here. This is going to be -1, and this is going to be 5, and the intercept is still going to be 1. So the idea is pretty much the same. The only difference is that I'm using a different variable. So now instead of using y, oh, that's not a highlighter. So instead of using y, now it's f of t, and instead of using x, now it's going to be in terms of t. That's it. Okay, let's have a look at another type of function. Let's switch to, so we have seen a straight line. So let's say a quadratic this time. So let's see if I have a graph of f of t. Now let's switch it in terms of f of t. I no longer am going to use y. It's going to equal t squared plus 3. Okay, so what happened is that when you have a quadratic graph in a form of at squared plus bc, sorry, it's going to be bt, not bc. So that's a bt plus c. So your coefficient is going to be a, b, and c. C, of course, so it's still going to be the intercept. So it's still going to be the y-intercept, alright? So the value of A is going to determine whether it's going to be a smile graph or a sour graph, concave up or concave down. So when A is greater than 0, so it's going to be a smile graph. It's a concave up graph. And when A is less than 0, it's a negative value. So it's going to be a sour graph or a concave down. Okay? So for this case, I have a value of 1 as my a value, right? I don't have a value of b. So if you don't have a value of b, meaning that, so if your b is equal 0, what happens is that the axis is going to be right in the middle of your curve. For example here, so what happened is that I know that this is going to be a concave up. It's going to be a smile graph because my a value is going to equal 1. The intercept is going to be at 3. Okay, for example here, there's going to be a value of 3, so it's going to be concave up. So when I sketch, I know that the graph is going to look like this because my b value is equal 0. But if your b value is not equal 0, then the curve is not going to be at the center. It's going to be something different. But for now, just for this chapter, I'm just going to stress the case when you have b equal 0. Well, let me give you another example. So let's say if I have f of t is going to equal negative t squared. And for this case, we know that our a value is going to equal negative of 1. So that is less than 0. So it's going to be concave down. So when I sketch the graph, it's going to look like this. So where is the intercept? So the intercept is going to be at 0. So that is going to be where my f of t is equal 0. So therefore, the graph is going to look like this, right in the middle, because b is equal 0. Right? So that is going to be the case of quadratic graph. Okay, now let's have a look at another one. So which is going to be simple, and it has a specific name as well. So if you are a direct entry student, and I know that some of you has done your basic maths with me before, so we have seen this in basic maths. When you first entered UMP, remember the first subject that you do, first course is basic mathematics. So this is definitely in there. And if you're not from UMP diploma, even you must have seen this somewhere. So I'm going to start with a very simple function. Let's say I'm going to have t from -1 to 0. So let me think about how it looks like. Let me put it as t plus 1. T plus 1 from -1 till 0. And then I'm going to have it as being 1 from 0 until 1. Okay. So what happened is that there's a specific name for this function. It is called as a piecewise function. Why is it called as piecewise function? Because at different domain values, at different value of t, you're going to use a different function. From -1 until 0, you're going to be using this function, t plus 1. And from 0 until 1, you're going to use this function, which is a constant function, f of t equal 1. So we know that this over here is simply going to be a straight line. So if you cannot imagine it in terms of f of t, this is actually graph of y equal 1. It's simply going to be a horizontal line. But for this case, so let me put over here. So for f of t is equal t plus 1. So now let's start to find values of that. But before that, let me put the axis first. So it's going to be from -1 until 0 and 0 until 1. So that's how our graph is going to start and end. And of course, this is going to be f of t. And on this side, I'm using variable t. Okay, when I substitute the value, okay, using this particular function, so when my t value, so I'm going to pick the lowest and the highest value, which is going to be here, -1 and 0. When I substitute that t is going to equal -1 in here, I'm going to have that f of t is going to equal -1 plus 1. That is going to be a 0. So when my t value is equal 0, my f of t is now going to equal 0 plus 1. So that is going to be a 1. So that is going to be my coordinate. So the first one is going to be -1, 0, which is right there, and 0, 1, which is going to be up here. And I know that this is going to be an equation of a straight line because t is to the power of 1. Remember, when you have y equal mx plus c, when x is to the power of 1, so this is going to be a straight line. If it's to the power of 2, so it's going to be a curve. The only difference is that instead of using x, we're using t. That will be the only difference. So therefore, I'm going to connect these two together. So that is how the line is going to look like from -1 until 0. So that's my first function. So I'm now done with the first one. I'm going to start with the second one. But again, this is just a graph of constant y equal 1 or f of t equal 1. So this is where f of t is equal 1. So it's going to happen from 0 until 1. So this is 0 until 1, so therefore I'm going to have a straight line. So that is how it looks like. So that is going to be my function. Okay, so it's simply going to be a straight line from -1 to 1, an increasing line, and a constant horizontal line from 0 until 1. So when you come across multiple functions that is being used at different values of t, so this is known as the piecewise function. This is going to be the most common type of predict function that you're going to come across. Okay, so now we're going to start with the